Okay, let's get started. There were two problems on the homework that I put it in too soon, so I'm sorry about it. It was done by another teacher, and they're such a cool questions. I just couldn't wait until it was, justly assignable to you. So I jumped the gun on that one. Sorry. I thought I'm gonna show you. There were two questions. Let me see. This was one of them. So if you look, I withdrew those questions. Everyone got the maximum point for it, and I withdrew it. So your grade did not suffer, but it's demoralizing. So I still feel bad. Like I cannot undo it really. So sorry about that. But I just want to show you what you needed to do. I did this mistake on the exam, and the first thing I did, I showed you the stuff that you need. So you know what the Pythagorean theorem is? Nobody, you're all here. It's the most famous theorem from geometry. The Pythagorean theorem is correctly stated in the chat box as long as we know who A, B, and C are. Who are A, B, and C? All right, so the Pythagorean theorem has two parts. Part one says the following. If A, B, C, so we're going to use standard labeling. A, B, C, those are the 3 points, is a right triangle. And usually we like the hypotenuse to be C, but you should never assume that. If you start with a triangle, yeah, A, B, and C, and we like to label the hypotenuse as C, but when you walk into a math problem, you don't know, maybe at the end it turns out that B was the hypotenuse. So it's just a sloppy habit that C is the hypotenuse. Don't assume if you have unknown things. So suppose we have a right triangle, where right triangle means it has a right angle. We must have talked about that stuff for the area of the right triangle, yeah? Right? We have to figure out the longest side, which is opposite the biggest angle, which is the one we don't use for the area formula. So I'm pretty sure you're well versed in hypotenuse and all that stuff. So if we have a right triangle and C is the hypotenuse, then indeed A squared plus B squared equals to C squared. That's one of the most famous geometric theorems. Now, usually if you add two numbers and you square, the sum is nasty. Like if A is 1 and B is 2, then C is not going to be nice. C squared is going to be 1 squared plus 2 squared. C squared is going to be 5. A number that squares to 5 exists, but it's terrible. Such a number exists, but it's bad. So there are these famous number triples, and there are infinitely many, but it feels like there are finitely many because we want to keep the numbers smallish. And then there is just a few of them, 3, 4, 5. 3 squared plus 4 squared is 9 plus 16 is 25, which is also 5 squared. Whenever there is word problem on this, people write down this square plus that square is, and then they say, I want to take the square root of both sides, which is fair, not a good idea, but fair. And then they go A plus B equals C. Remember, that's not even a triangle. 3 squared plus 4 squared is 5 squared, but that doesn't mean that 3 plus 4 is 5. So you have to be careful with the algebra. So 3, 4, 5 is an interesting one. And then if the shorter sides are 5 and 12, can you use the Pythagorean theorem to find the longest side? If this is 5, this is 12, how long is the longest side? Use the Pythagorean theorem's first part to find the hypotenuse. You square 5, you square 12, you add, and you hope it's a square, right? Indeed, the correct answer is in the chat box. And the smallish Pythagorean triples, as they are called, they're kind of famous. You're going to recognize them. Indeed, C squared is 5 squared plus 12 squared, which is 25 plus 144, which is 169. I just want to make a side note. Now, I was not planning to have such equations yet. I just kind of made it happen by including a problem in the homework that I shouldn't have. And I want to show you. This equation has two solutions, not just one, but two solutions. There are two numbers that square to 169. One of them is 13. The other one is negative 13. This arrow here is short for the following. The two solutions, 13 and negative 13, both work with the equation, but C is a distance, and distances cannot be negative. So negative 13 is ruled out. That's a lot of writing, but all I'm asking is that you replace it with this. But there is an important step here, that there is algebra, and algebra spits out all the numbers that work. And then we take the result, which is again two numbers, 13 and negative 13, and we interpret them within the context of the problem, where negative numbers cannot play a role of a distance. I blame the Pythagorean theorem that I see a lot of real bad videos on the internet when from here they go to 13. And I blame the Pythagorean theorem and or YouTube for that. So I'm just going to make this deal. Like, you don't have to write all this like I had to. But if you don't do this, you just go from 169 to 13, you're going to lose some points there. Because I need to know that you know this equation has two solutions. Okay, but it is 13. Very good. Now, part 2 of the Pythagorean theorem says that, and only right triangles do that. Other triangles don't. So part 2, if ABC is any triangle with sides, and I'm not even going to use A, B, and C. Actually, I'm going to use PQ and R for points. PQR is any triangle with sides PQ and R such that P squared plus R squared equals Q squared. Then, so in the Pythagorean theorem, whoever is alone, that's the hypotenuse, that's the longest side, that's opposite the right angle. Then the angle opposite Q, opposite side Q, is a right angle, which is the same as 90 degrees. So part 1 of the Pythagorean theorem says, here is what right triangles do. And part 2, and only right triangles do that. So you can actually test 3 numbers. If I say 6, 7, and 8, is this a, 3, 4, 5 was so nice. Maybe this keeps up. Could this be a triangle? Could this be a right triangle? I mean, could these be the sides of a triangle? Could these be the sides of a right triangle? So that's 2 questions. So if you test the triangle inequality, any 2 you add has to be more than the third one. The only one you really need to check is 6 plus 7. Is that bigger than 8? Because 8 plus 7, of course, is going to be bigger than 6. 8 plus 6 is going to be bigger than 7. So if all 3 numbers are known, you just grab the 2 small ones and see if they... so yes, it's a good triangle. And for a right triangle, we have to check 6 squared plus 7 squared. Is it 8 squared? I already see that that's not going to work because guess what? I'm sorry, 6 squared is even, 7 squared is odd, even plus odd is odd, and this looks very, very even to me. So I don't think this is going to work, but we're just going to check it out. So 6 squared plus 7 squared is 85, 8 squared is 64. So these two are not equal, so this is not a right triangle. Now, when you're given a triangle, it's not enough that an angle looks like a right angle. It's either has to be stated on the problem, or there is a way on pictures to state that it's a right angle. This little mark means that is a right angle. In my country, it's just a cute little dot, but there is a symbol for it. So after that, I can tell you that homework problem. With my apologies, I never want to give you math problems you cannot solve within. All right, so there were 2 of them to make it. I was just so excited about this guy figured out how to answer with units and beautiful pictures. Check this out. He changes the colors too. We have to figure out the perimeter of a shape where basically someone bit off a right triangle from a rectangle. So for the perimeter, we can say, okay, let's start here. This is going to be our starting point. Units are in feet. So we could say that, let's start walking around, that this is 31 feet plus 57 feet plus, this is 31 because it was a rectangle from which we bit off this right triangle. That is the little symbol. And this is 31 feet. But now we're in trouble here. we can add these two, but what about these two? And the cute thing is that we can't find both of them, but we can find the sum of these two. Imagine that we're moving this thing around. Basically, let's just figure out first, what is the hypotenuse? This is almost an isosceles triangle because 20 and 21 are so close to each other. What is the hypotenuse of this triangle? By the way, I don't do A, B, and C. I just use X wherever I need X, but that's completely up to you. So what is the hypotenuse? Can you find it for me, pretty please? Indeed, 20 squared plus 21 squared is 400 plus 441, which is 841, which so happens is 29 squared. I think it's time for us to figure out how to take the square root of a number. So here is the square root symbol right there. That's the square root symbol. It's written with blue, so that means first you have to push the second. And with this calculator, you always have to enter stuff in the same order you would pronounce or write those. So square root of 841, we're going to push first square root. I just need to zoom out. So we're going to go second square root 841, 29. That's nice. Okay, so here is what happened. We started to walk. That is 31, 57, 31, and here there is a big question mark. And I would say this side here, start with 57, right? That would be this. And then lose 29 and add, right? This one here was taken out. This we now found out is 29. Lose that, and then add 20 and 21. Doesn't make sense? And I was like, oh, those two sides are there. It's perimeter. We don't have to worry about, but we don't know what this is. This is basically what you get when you lose 29 from 57. And then mentally, you can move this thing around and it doesn't change the area or the perimeter. Just move that thing around mentally. So basically, the perimeter is starting from here, 31 feet plus 57 feet plus 31 feet again, plus, and we can say, okay, we're just going to rewrite this stuff here. So start with 57, add 57, lose 29, and add 20 feet plus 21 feet. By the way, by the triangle inequality, this will always increase, right? This is shorter because this is the shortest distance. So fencing the original rectangle would be cheaper than this one. We lose 29, but then we gain 41. And so that should be the correct number. Let's see, in feet. What is this? So what do we have? We have, okay, I'm going to try to get, you have this calculator in front of you, right? Okay. So we have 31 plus 57 plus 31 plus 57. That's just a rectangle. Twice this plus twice that. But then we lose 29. And then we add 20 plus 20. 188 feet. And this is always a moment in mathematics that was just so lovely when you check and it checks out. Where the hell is that window? So we think it's 188. If I enter 188, it's not going to like it because it should be 188 feet. Yay. Oh my God, there is a part B. That's another thing I didn't know. This is a scaffolding. This guy runs circles around me when it comes to programming. What is the area of the shaded shape? That now we can handle because it would be the area of the rectangle minus this area, right? Let's figure it out. So now let's figure out the area. So the area would be the original rectangle. What was that? Is this still zoomed in? So the area is the area of the rectangle minus the area of the triangle. Yeah, that's pretty, someone bit off this. So I feel these Monday mornings. Okay. So the area of the rectangle is 31 feet times 57 feet minus the area of the triangle is, well, every right triangle is half of a rectangle, so it's 1/2 of 20 feet times 21 feet. So this one I give up. I'll just use the calculator. 31 times 57. 1767. 1767 square feet. Feet times feet is square feet. Minus 20 divided by 2 is 10. So 10 times 21 is just 210 square feet. Feet times feet. Every area should have. Maybe I can do this without the calculator. 1,557 square feet. One, 557 feet. Yeah. Okay, and there is no, oh, submit. There's no third part thing. I didn't know about the second part. There was another question on the homework done by the same guy, very similar. That was, I think, about areas, but I'll dig up that one too. I lost it. So I believe this is the one we just saw, but I had to regenerate it. And if I go, this is his too. This is so cool. Draw a triangle with an area of 14 square units. Any ideas? Any ideas? Come on, this was a fun problem. Well, base times height over 2 should be 14. That means base times height should be 28. Base times height is 28. I'm thinking 4 and 7. So 2, 4, 6, 7. And anywhere where the height is 4 should work. Anywhere. These all have the same area, even this crooked one. What is the perimeter of the? Now, this one is a tough one with perimeter. I didn't know about the second part. Damn. Because hit 7 and then 4. But we cannot do the perimeter without the Pythagorean theorem because this side is 4, this side is 7. But what about this side? But it's something nasty by the Pythagorean theorem. So sorry, I didn't even knew about that. Okay, this was the other one. So I'm just gonna take down the numbers. Again, some bit of a right triangle from a rectangle, but now it's different part of it. Now it's the hypotenuse is the only thing that's visible. So let's see, 79. Ugh. Okay. 94. Find the area. Okay. So I think the area is going to be, again, we could find the area of the rectangle, this rectangle, and then subtract the area of the triangle, right? So it would be the area of rectangle minus the area of the triangle. The area of the rectangle, I forgot the units, is yards. 79 yards times 94 yards minus the area of the triangle. Now we're in trouble because we don't know. For the area, we would need these two sides, and we don't know either one of them. We just know that this hypotenuse is 37. That's useless. And for the Pythagorean theorem to be useful, we have to find another side of this little triangle. Any ideas how we find one of the two missing sides? This is 67, and this is 79. So what's missing is the difference, right? Looks like 13 to me. No, it should be 12. I just know my Pythagorean triples. Right? This was given because this side was given and the opposite side that's longer, and their difference. This is kind of a visual version of a word problem where you have to see those connections that there. You just have to have faith that everything I have. Now, to find this, find the Pythagorean, use the Pythagorean theorem. So chop, chop, find the missing side. It's not the hypotenuse you're looking for. So this time x squared plus 12 squared equals 37 squared. And then we're solving for x. That's not the hypotenuse. So when I said square root, it erased the number, but you can recover it. Here, this is answer in blue. So you go second and that. You see ANS is, yeah, I want the answer square root. Oops, I'm sorry. It's 35. And so now we know that the triangle's area is going to be 35 yard times 12 yard over 2. 35 yard times 12 yard over 2. Thirty-five times 12. This is terrible. Over 2 is 210. So some yard squared minus 210 yard squared. 79 times 94. 79, that's a big number. 79 times 94. 7426. And so that difference is 7,216 yards squared. So it all boiled down to the Pythagorean theorem. My bad. Let's check. Seven, 216 yards. Yeah, we got it right. Oh, and there is no second part, thank God. Okay, all right, so my apologies, but now we covered the Pythagorean theorem. The Pythagorean theorem is really, really, really important. We're just gonna do small, every homework, we'll have some new Pythagorean theorem question. Just gently dose it. So my bad, sorry about that. Any other questions? Again, everybody got the full points for these problems. Okay, so we should definitely move on with fractions. Fractions part 3 is next. So something is going to change. Until now, I was telling you, think of a pizza. Like here is a pizza, we cut it into what fraction expresses this much of a pizza? Five over six, exactly. But now suddenly I want you to imagine that you're working in a pizza factory and there are lots of pizzas. Until then, we were friends sitting down and there was just one pizza and we could just get parts of it. Now we're gonna extend this and imagine that we are working in a pizza factory. Now, this is what we're gonna talk about is improper fractions, which most of them, there is nothing improper about them. I don't like the name. It just suggests that there is something wrong with them. Versus mixed numbers, which are beloved and overused in the American curriculum. They're not as fancy as, all right. So here is one pretty obvious improper fraction. This would be 6 over 6. Now just think of it as a division problem. 6 over 6, that fraction is going to be equivalent to the number 1. 1 pizza, right? But we can also have what would this fraction mean? What fraction could you express this? This many slices. Not 8 over 12, 8 over 6. That's kind of the point. So we're stepping outside of a proper fraction is when you can't have more than what's in one pizza. Right, so improper fraction is when the numerator is too big. It's either equals to the numerator or even bigger, like 8 over 6. That's what makes it improper. And then a mixed number, think of it as bills and coins. So we can think of this as one pizza. And then what's left is 2 over 6, or if you feel like reducing, but actually technically this is the one. So this is the improper fraction. And this is the mixed number. And if you're drawing or making something out of wood, you probably need a mixed number. Something like 1 and 2/6 of an inch. But any other purpose, you never need a mixed number. They're just terrible. Inside of a computation, whatever you want to do to a number, probably you're going to have to switch to improper. Like basically, mathematically, this is such a disadvantage. So there is nothing really improper about it. In fact, I will always accept improper fractions as long as they are in lowest terms. So officially, in this class, 8 over 6, not cool. 8/6, not cool. 4/3, officially not simplified. It's fine for me. As long as it's in lowest terms, it doesn't bother me if it's an improper. In fact, higher level classes, you will prefer the improper fraction. I wish I thought about this and showed you a calculator that's made for calculus classes. It doesn't even bother with mixed numbers. In fraction mode, it's just going to give you stuff like 4/3. 1 1/3 is fine. You don't have to do this for me. You can do if you want. You will never lose points, but that's an extra step that I think this is over. I think mixed numbers are highly, highly, highly overrated at this point. So they're gonna learn a little. They're gonna take them down a notch. Okay, all right. Let's do more pizzas. So let's agree that every pizza is cut into 6 slices. Okay, so we're in a pizza factory. And one pizza, I guess we can write it is 6/6. So it's 6. This is how many we take, and this is how big, i.e. how many makes up a whole, right? How big. So this tells us we cut each pizza into 6 slices. Okay, and imagine that we're at the back of the kitchen and we're packaging pizzas, and our job is, if we don't have to cut, we don't cut. So if someone orders 8 slices, that would be 8/6. We're not going to package 8/6. We're going to pack a full pizza, and then 2/6 or even 1/3. Oh, I messed up the picture, didn't I? So basically, if they ask for more than 6 slices, we don't have to cut these 6. They can, that way it doesn't cool off so quickly. They can cut it for themselves. And then let's just agree that the ones that are caught, immediately caught, you have a machine that you either leave it alone or slice it into 6 slices. So that means this is 1 and 2/6 as a mixed number. It's not reduced because this should be 1/3. All right, so write it as a mixed number and an improper fraction. Actually, write it as an improper fraction and a mixed number when someone orders 23 slices. What improper fraction does that mean, and convert it into mixed number? Oh, come on. This is a review from way back. You guys know this. Imagine that you're packing. So 23, that's a lot of slices. You grab a full pizza, that's 6 slices. You don't have to cut. Just shove it in a box, done. Grab the second box. So it's not, you could do this job, so you can solve this problem. That would be, so 3, that would be, how did you get 3? So 3 is in my private chat box. You don't see it, but So the improper fraction would be 23 over 6. 23 slices such that 6 of them makes a whole. That's 23/6. And yes, this has a lot to do with division with the remainder. Because indeed, if you divide 6, if you divide 23 by 6, it's almost 4, but not quite. And you can actually use the calculator. It's just you just need to know what to ignore. You can, if the numbers are bigger, you can punch it in 23 divided by 6, but then you have to ignore everything after the decimal. It's 3 and change. Now, 3 full pizzas, that's 18 slices, right? And, or 18/6 is 3. Oh, that's where you got the 3. Yep. So you were right about the 3. And then we need 5 more slices. Actually, the correct answer, 18 plus 5 will give us 23. So it's almost 4 full bucks, right? 1 more slice, 24, and that would be 4 full bucks. You can think sort of backwards, like take full boxes and then take out 1 slice. That leaves 5 over 6. Okay. Let's do 1 more. $16 slices. Give me an improper fraction and an equivalent mixed number. Are you guys in the North Pole? It just seems so long. There must be a time delay or something. Come on, I mean, 16 over 6 should not take a lot of thinking, right? Oh, you already come up with the, okay, that's understandable. So the improper fraction would be 16 over 6. Not reduced, 8 over 3 would be reduced, but that's not the issue. And then that's 16 divided by 6 is 2 and change. Because twice 6 is 12. 3 times 6 is 18. That's too much. We cannot have 3 full boxes. So we're going to have 2 full boxes. You can ask the calculator, although I don't think you particularly need it. 16 divided by 6 is 2 and change. But then you have to ignore the rest. And then 2 times 6 is 12. What's left is 4 out of 6. So again, the correct answer was quickly in the chat box. Okay. All right, let's go backwards where we start with the mixed number and you come up with the improper fraction. That's, you know, you got promoted. Now we're at the register and we're ringing up people by the slice. So here is an order, 5 full boxes plus 4 slices. Write it as a mixed number, write it as an improper fraction. The way I'm giving it to you is suggesting mixed number. What mixed number would this be? What mixed number would this be? Uh, 5 and 4 over 6. 5 and 4 over 6, right? Which is the thing that's 34 slices. So you would ring up for each box has 6 of them. 6 times 5 is 30 plus 4. So it's 34 over 6. 34. Oh, 34 slices. So that's kind of, you should be able to go back and forth. Again, whenever you have to manipulate things, well, addition, subtraction, mixed numbers are okay, but multiplication, division, you can't do it with mixed numbers. You have to go to the improper version. The other thing that we could do that's kind of makes it easier to understand, you see, I don't want to tell you how to do it. I'm telling you what it is, so you can always refigure it. You can sort of figure out the algorithm because you understand what these things are. That way, you can always recall it correctly. If I give you a meaningless algorithm, that is not a good thing to have because you forget it 2 weeks later and you're not sure. Was it multiply? Was it divide? Do I subtract? So I never like to give you an algorithm like here is how you do it instead of what are these things. So let's say that we're talking in dollars. And then let's agree that 1 dime is 1/10 of a dollar, right? And we can have more than $1. So what would this be as a 23 dimes? 23 dimes as a mix, as an improper fraction is 23 over 10. Well, can you make change? Like you have too many coins, too much coins, pulls down your pocket. Can you express this as a mixed number? I know it's easy, but that's all right. This as a mixed number. Yes. $2 and 3 dimes, right? Whatever you can, you exchange for dollars. That's why I like the analogy with dollars and coins and bills. All right, so there is one more thing. Now you understand how, if we can have more than one pizza, we can have these weird fractions that it's not just a genuine part of a whole, but more than a whole. It's a whole and then parts of a second whole, or two whole and parts of a third. So once that's possible, we can talk about percentages over 100%. 1 is 100 over 100, which is 100%. If someone tells you, I'm behind you 110%, they probably don't mean what they're saying, or they don't, not all of them is possible, but you can increase something by 110%. So pretty steep increase, but so let's go back and forth, express first 35 over 10 as a percent. And as a mixed number. No, 3.5%. So this is a good conversation to have. That's 3.5%. That's very, very small. That's 3%, right? That's not what you're trying to, it's 350%. So as a mixed number, it's 3 and 5 over 10 or 3.5, right? But as a percent, that is 35 over 10. We want a denominator of 100. So we're going to multiply upstairs and downstairs by 10. And indeed, that's 350%. And so if a number is bigger than 1, then the percent is going to be bigger than 100%. You cannot, well, if we have a certain population, you cannot lose like 350% of it, but you can have a growth of 350% growth easily. Now let's see, let's go express 275% as a mixed number. I guess, no, as first an improper fraction, as a reduced improper fraction, and you can always stop there for me, and then as a mixed number. I think that's the logical order, mixed number. 275%. Improper is just, oh yeah, fine. Just write 100 over it, right? That's what percents are. And then we can start dividing by, I definitely see some 5s. So if we divide 275 by 5, we get 55. If we divide 100 by 5, we get 20. We can go one more time, and that's 11 over 4. Oh, that's here, 11 over 4. And then what mixed number can we make out of this? This is a mixed number. Eleven over 4 as a mixed number. Yep. I guess we can say that's 200%, which is, that is the 2 plus 75%, which is 3/4. But yeah, 11 divided by 4 is 2 with a remainder of 3. Excellent. Good job. One of you already knew this or learned it now. Either way, I'll stop here because it's quiz time. So the quiz should already be visible if you refresh your page. I checked before class because I'm getting senile. Actually, it's not visible yet. I just see that the settings, it's gonna become visible at 1:30 p.m. There is a new feature. I can now yell over. I could broadcast stuff by printing something and everyone would see. Now I can actually talk to all of you like Big Brother into each room. I'm gonna try not to use it. Sounds a little scary. But I'm gonna put you in the breakout rooms, and then I think you should stay here until you see the quiz is visible. And then I'm asking for steps shown for 2 problems. But if you want to show more steps for more problems for partial points, the last problem has and the last question is not a question, just a mechanism for uploading whatever else you want me to look at. You know the drill, it's the same, right? Okay, it's 30 on my, do we have it. So if you refresh the page, it is visible now. So I'm going to open the rooms. If you need help, you can come back or summon me. If you're done, have a nice weekend. You don't have to come back to the main room. But you can and I'll check if things are posted. You should also be able to see from the grade book what you uploaded and what you didn't. The grades are not going to be visible yet, but you can still check whether stuff is uploaded. All right, I'll shut up with this. Oh, maybe I don't have to record this.